Sorry, counting down. All right. So, hi, how's it going, everybody? So, today is our second day into Intro to Geometry. We're going to be talking about vertical and adjacent angles for today. So, what should you be able to do? Now, we're going to be able to talk about missing angles when it comes to complementary, supplementary angles. We're going to be dealing a lot more of that tomorrow. But today is the beginning of our talking about adding angles together and finding a missing piece. So vertical angles, what are they? The angles opposite from one another when two angles intersect. Sorry, I have my kitty. Here's my kitty. Say hi, kitty. Good kitty. Here's the kitties. Here's the kitties. She is not liking this. Oh, she ran away. Uh, and adjacent angles are two angles that share the same common side. Basically, vertical angles, you're going to draw an X, this angle right here, and this angle right here. They're opposite each other. Those are vertical angles. Adjacent angles, meaning this angle right here touches this and with this one, with that one. There we go. Sorry, everything's backwards. So this angle right here and this angle right here, they're adjacent because they're next to each other. So how does vertical angles look? Vertical angles look like this. Ooh. So angles are equal. That's one big thing about vertical angles is that, for instance, angle 1 is equal to angle 2, and then angle 3 is equal to angle 4. For adjacent, no common interior point, meaning like they're right next to each other. It's not like inside of one of the angles, and they have a common side, so this side right here, and they share the same vertex. So angle 1 and 2 are adjacent to each other. Okay, so let's do a couple of examples for both. So solve for the missing angle below. Oops. So if this angle is 78 degrees, I want to know what would this one be. So if we look at our example up on top, angles are equal to each other if they are vertical angles. So question for yourselves, are these vertical angles? Are they on opposite sides of each other? Do they form an X? Yes. So what does it mean? What is my answer going to be? What is X going to be? Well, if this is 78, then that must mean that X is also 78. So then my answer is 78. Now, notice how I have my work here and then the same answer is here. That's kind of how your homework's going to be. You're going to write your equation in the box and then your answer is going to be here, where not with an X, just with the answer. All right, just to keep that in mind. Anywho, solve for the missing angle below, given that angle 1 and angle 2 equals 113 degrees. So does it matter which is angle 1 and angle 2? No. It's just letting me know that this angle right here and this angle right here, if I add them both together, it gives me 113. So I'm going to take the X and I'm going to take the 47. I'm going to add them together and I'm going to have them equal 113. Now, think back. This is a one-step equation. So how can I figure out what X is since I have this plus 47 here? Well, what I can do is I can get rid of this 47. It's positive, so I want to do the opposite. So I'm going to subtract 47 from both sides because whatever I do to one side, I have to do to the other. So I'm going to get X equals 113 minus 47 gives me 66. So the answer I'm looking for is 66. What is that? That's just the X here. So can you check? Yes. 66 plus 47 gives me 113. So as long as that equals the same, then you know that you did the math right. If it doesn't, then go back and check yourself again. So many comments. All right. So again, this, you don't have to copy it down again because this is more information or the identical information of what we already talked about. But just in case you wanted to see it in a different way, here it is. If you want to copy it down, by all means, press pause and copy it down. So adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. So 1 and 2 are adjacent points, adjacent angles. 3 and 4 are adjacent angles. Vertical angles are two angles whose sides are on opposite rays. So 1 and 2 and 3 and 4. All right, let me move this guy over. So identifying angle pairs, use the diagram below. Is the statement true? And explain. So what I'm trying to find out is if BFD and CFD are adjacent angles. So plan, what should you look for in the diagram? Check whether the angle pairs match every part of the definition of an adjacent angle. So what am I looking for? BFD, BF and D, and CF and D. So let me highlight that. So adjacent angles have a common side. They have a common side right here. A common vertex, yes, common vertex, and no common interior points. This guy is inside of angle BFD. So that is a common interior points. So this does not work. So BFD and CFD have a common side and a common vertex, but they also have a common interior point. So does this work? No. Oop, I need to move my guy over again. So no, they're not adjacent. So the statement is false. So again, why? They do have the same side. They do share a vertex. However, because this is inside of it, it doesn't work. All right. What about this one? A, F, and B, and E, F, and D are vertical angles. So does that look like vertical angles to you? Vertical angles are formed by two pairs of opposite rays. Opposite rays means if I put a point right here, then one part of my line goes one way, one point of my line goes the other way. So this is opposite rays. So there and there. However, if I go up this way, does the arrow go down this way? It doesn't. It goes off to the side. So it doesn't follow a line. Now, if they would have said this line right here to create this angle, then yes, if they would have done A, F, and C, those are vertical angles. But because they are looking for A, F, B, those are not. So it's false. All right, try this one yourselves. So use the diagram shown. Is the statement true? And explain. A, F, E, so A, F, and E, so that's at 62 degrees. And C, F, and D. Are these vertical angles? So yes, AFE and CFD are formed by opposite rays. Yes, AFE and CFD share a common vertex. By the way, I'm petting my cat. No, the sides of AFE and CFD are not opposite rays. Or no, AFE and CFD do not have a common interior point. So I'm reading these to give you guys point. What are you doing? What are you doing? Are you attacking me? What? Seriously? Seriously? My cat is attacking me. What is up with this? Really? I'm gonna see if I can get her. Oh, She just wants attention. Oh, it's the kitties. Oh, it's the kitty kitties. Oh, it's the kitty kitty kitties. Oh, it's the kitty 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 kitties. You're disturbing my video recording, kitties. Yeah, she's shedding, trying to get her summer coat. All right, I gave you pettings. Now go away. All right, so now you should definitely know what it is. All right, did you pick A? They have opposite rays, so AF, FD. So see how it makes a line. That's what you want to see. EF, FC. Don't attack my chair. All right. Intersecting lines. These are two or more lines that cross each other at a point of intersection. So intersecting lines don't necessarily have to look like an X. It could be like anything as long as they cross. That point where they cross is your point of intersection. PQ and RS intersect at point O. Point O is common to both lines. So PQ and RS intersect at point O. And a real life example of intersecting lines would be like a four-way intersection on the road. So that's a real life example. That should help you guys out. Parallel lines, most of you guys, like all of you guys should know about parallel and perpendicular lines. Parallel lines are two lines whose distance between them does not change. They will also never cross. Perpendicular lines meet at a 90-degree angle. So two rays, a line segment or lines are perpendicular to each other if they intersect or meet at right angles or 90 degrees. So parallel lines examples would be like the electrical lines up on top. This is a funny one. So perpendicular lines would be like this, because you know that happens all the time. So yeah, fun times. All right, reflex angles. Reflex angles you're probably not going to see very often, or at least not in this class. You're going to see it more in Math 2. So specifically, rewatch this when you're about to start Math 2, even if you're not in my class anymore, obviously, but rewatch this again whenever you're starting Math 2, because this is going to help you with that very first unit that you're going to be covering in Math 2 as well. So reflex angles is an angle that is greater than 180 but less than 360. So you have a line. A reflex angle is that extra piece of that line. So not a complete circle, but almost to that circle. So almost to that circle. A round angle would be like a circle. So it means that this angle has gone all the way around. So is an angle which measures exactly 360 degrees. So it's known as a round angle or a full angle or a full circle. All right, so how would you label that? You'll just label it as angle A is a round angle. Linear pair. Now, this is very similar to adjacent lines, adjacent angles. You're going to have a straight line and you're going to add two angles together to make a straight line. So linear pair of angles are two adjacent angles whose non-common sides are opposite rays. So angle 3 and angle 4 are linear pairs. So again, it's two angles that I can put together to make into a straight line. That should also equal 180 degrees. So if you want to add that, I'll talk more about that tomorrow. But if you add that, it's like, hey, this should equal 180 degrees. That would be beneficial. But again, all of this is vocabulary that you guys will need for this unit and next unit. So that's it for me. Have a good day, guys. Goodbye.